Have you ever wondered about those missing exoplanets between super-Earth and sub-Neptunes? Exoplanet scientists have enough data now to say that this gap is not a fluke. There's something that stops planets from reaching and/or staying at this size. So stay tuned till the end to go through the new theory. Planets outside our solar system are called exoplanets, which are of various sizes: small, rocky, or colossal gas giants. In the middle lie rocky super-Earths and larger sub-Neptunes with puffy atmospheres. But there's a size gap of planets that fall between 1.5 to 2 times the size of Earth, or in between super-Earths and sub-Neptunes. This gap could be explained by certain sub-Neptunes losing their atmospheres. This loss could happen if it doesn't have enough mass, enough gravitational force to hold on to its atmosphere. Planets that aren't massive enough would shrink to about the size of super-Earths, leaving the gap between the two sizes of planets. But how are these planets losing their atmosphere? Two likely mechanisms. One is called core-powered mass loss and the other, photoevaporation. Core-powered mass loss occurs when radiation emitted from a planet's hot core pushes the atmosphere away from the planet over time, and that radiation pushes the atmosphere from underneath. While photoevaporation is thought to occur during a planet's first 100 million years, core-powered mass loss is thought to happen much later, closer to 1 billion years into a planet's life. But with either mechanism, the planet doesn't have enough mass. It can't hold on and loses atmosphere and shrinks down. Scientists used data from NASA's K2 of the Kepler Space Telescope to look at the star clusters Praesepe and Hyades, 600 million to 800 million years old, as planets are generally thought to be of the same age as their host star. The sub-Neptunes in this system would be past the age where photoevaporation could have taken place, but not old enough to have experienced core-powered mass loss. If they saw a lot of sub-Neptunes in Praesepe and Hyades as compared to older stars in other clusters, they could conclude that photoevaporation hadn't taken place and core-powered mass loss would be the likely explanation of what happens to less massive sub-Neptunes. The researchers found that nearly 100% of stars in these clusters still have a sub-Neptune planet. Based on size, the researchers think they have retained their atmospheres. This differs from the other, older stars observed by K2, stars more than 800 million years old. Only 25% have orbiting sub-Neptunes. The older age of these stars is closer to the time frame in which core-powered mass loss is thought to take place. The team concluded that photoevaporation couldn't have taken place in Praesepe and Hyades, as it would have occurred hundreds of millions of years earlier, and these planets would have little, if any, atmosphere left. This leaves core-powered mass loss as the leading explanation for it.